Karthik, Soumya, Raja, Poonam, Kritika, Karthik.
Morning, sir.
Hi, sir.
हाँ भी दिख रहा है, बाकी लोग का वीडियो दिख। ओके ठीक है, क्लास स्टार्ट हो रहा है तो फिर हेलो
Yes, sir.
Hello, sir. Good evening.
गुड इवनिंग. So now,
Hear me, sir?
okay, so this slide is visible.
Yes, sir.
Okay. So basically, I wanted to start classical mechanics today, and a few problems we solved from the tutorial, and I posted a screenshot of the solutions on the app.
Yes.
Okay, and other problems are also there. We will solve them eventually. Today, actually, I wanted to start classical mechanics, but so what we will do today, I will just discuss about syllabus and what kind of things we are going to follow. Kritika,
Yes,
wasted 1 hour. So basically, I wanted to tell you today that there are a few topics. We have part B and part C. So in part C, there are a few topics which are common in part B and part C both. And there are few topics which comes in part C only. So nuclear and particle physics only in part C, and condensed matter physics and atomic molecular. These three topics comes in part C only. So you can expect 3 or 4 long questions from this part. Basically, part C carries 30 questions. Out of 30, you have to attempt 20 questions. Okay. So
Yes, sir.
from these parts, which are basically specifically for part C, this is atomic molecular, condensed matter physics, and nuclear and particle. So we have studied nuclear and particle physics, and we can expect 3 questions in part C from this. So we can say 15 to 20 marks from this part. And condensed matter physics and atomic and molecular, the other sir who is taking your class, he will be teaching you. So probably he is teaching you solid state physics. So he will take this other part. So I am taking classical mechanics, and one part this mathematical methods for physics, and one is electronics and experimental methods. So these 3 parts, they are common in part B and part C both. So here we are starting with classical mechanics as of now, because that will be better when you will be studying quantum mechanics, and also this will be a basic thing that will be better if you're prepared with that part. So from this part, we can expect 4 questions in part B and 3 questions in part C. So means it has about 30 marks. So we will solve both type of question for them. Part B carries 3.5 marks question, and part C is 5 marks question. So here we will take small and bigger. Since both kind of question we will deal, we will do more tutorials and we will solve more questions. So one book I particularly recommend, if you can have, one is J.C. Upadhyay's book on classical mechanics. I have a soft copy of that. I can share it with you if you want, if you don't have that copy. So that book is good. We can take question from that. We can study if we need. So that is a reference book we will be taking. And then most important thing is that we have to concentrate on syllabus, and we will do more questions. So here part B, syllabus for part B, this Newton's law, dynamical system, phase space dynamics, stability analysis, central force motion, two-body collision, scattering in laboratory and central mass frame, rigid body dynamics, moment of inertia tensor, non-inertial frame and pseudo forces, variational principle, generalized coordinates, Lagrangian, Hamiltonian, formalism and equation of motion, conservation laws and cyclic coordinates, periodic motion, small oscillation, normal modes, special theory of relativity, Lorentz transformation, relativistic kinematics and mass energy equivalence. This is in part B. So we will do an total class on special theory of relativity, where we will discuss basics of special theory of relativity, fundamentals, means postulates, two postulates, and then basic formulas, and then Lorentz transformation, its invariance, and then mass energy equivalence for that. And then after that, we will solve all the questions from last 10 papers from a special theory of relativity. So we will do this in a single class. And today we will take some basic definition. We will revise. I was planning to have a small test so that we can have an average idea where we are going to start, and then we will revise some basic definitions, and then this means we are making it a classification, one for special theory of relativity, other one is Lagrangian and Hamiltonian formalism. This actually mechanics is quite one is the Newtonian mechanics. We generally start with our school classes and all. So there also there are some question, there is spring constant and friction forces, that kind of questions. If you look at their paper, and central force, so that kind of thing. So first one class we will cover this theory of relativity, and we will take two classes, at least 2 hour classes for Lagrangian and Hamiltonian formalism, equation of motion, conservation laws, and cyclic coordinate. So these things we will take in 2 classes. And this periodic motion is small oscillation and collision and Newton's law dynamic system. This will take in 1 or 2 classes. So these are the some basic part we will do. Means we will devote more time for it as compared to nuclear and particle physics, because nuclear particle physics carries about 15 marks, and this portion carries about 30 marks. And then part C, this dynamical system, phase space dynamics, stability analysis. So there are few things you can see. This is common here. So that topics we will go into greater detail when we are studying this topic. Poisson bracket, canonical transformation. This comes when we are dealing with the Lagrangian and Hamiltonian formalism. Symmetry invariance, another theorem. These are the topics. Basically, we will concentrate ourselves in syllabus, and we will refer exam questions for practice, for tutorials. So I am thinking to divide our class in a proper way, that we will have few lectures, and we will have tutorials, and we will make some assignments, because by just doing class, I think it's not good to expect to have a better expertise. So you have to practice. So we'll make some assignment sheet and share it with you, and then you solve. And if you have problem, then we will discuss. And we have tests. So there are 4 kind of mechanism we are going to follow, because this mathematical methods, they also need a lot of assignment. So some lectures, some tutorials, and some assignments, and some tests. These are the 4 techniques we are going to use. And for so here I make actually very limited content for today. So it was generally, I was expecting to have a small test, and then some basic understanding of today's class. So it is basically introductory class on classical mechanics. So that I wanted to discuss with you what kind of part you feel comfortable, or we need to start from very basic, or it's the kind of thing I was expecting to have a test, but this test thing, I don't know how to start here. Want something, some other technique, some other thing, because we studied nuclear and particle physics, and still we have some questions to solve. If you have some inputs, if you want something specific in your class, or if you want me to take some other initiative, if you have suggestion, you're welcome. So I would like to hear you if you have some other suggestions for conducting this classical mechanics.
Yeah, sir, you can give some problems to solve. You told that about assignment. That we
Yes,
will solve
Soumya.
later.
Soumya, you were saying something, but there was some problem. Please, can you repeat it once?
Sir, you can ask us to solve some problems, not while class because we waste the time. For next class, we can
Yeah.
solve some problems. If you give some problems,
As an
Okay.
assignment.
So one thing means,
so even we will get the
Poonam, you
idea
wanted
that
to
what
say
type of
something?
problems will come from
Okay.
each
Sir,
topic.
I'm just saying that any kind of assignment for us so that we can practice more questions.
Okay. So what I will do from next class onward, I will select a topic. As I told you that we will divide this syllabus in some parts. So we will have a special class and a special theoretical activity, and we will do all theory of it, and we'll try to solve some problem from exam point of view, and we will make some assignments. So we can make some easy question, means level 1, level 2 kind of, some easy question for practice, and 20, 30 question as assignment, and I will share it after class. So you solve it, and if you have any issue,
Okay,
share it.
sir.
Okay. And so in class, basically, we have more lecture mode, and when we will conduct tutorial, then we will discuss problem.
Yes,
I
sir.
think that much, that thing is better.
Yes, sir.
Kritika,
Yes, sir.
do you have any suggestion? I can see you, but I told that we have done this nuclear and particle physics part.
Okay.
So on the basis of that, if you have some feedback when we are starting some new topic, classical mechanics, this is more scoring. It contains approximately double than nuclear and particle physics. If nuclear particle physics is 15 marks, then classical mechanics will give you 30 marks. So we
30.
will do it more rigorously. So for that, I think we have to do a lot of problems. We need to solve it. Okay.
Okay, sir.
So I have in my mind that we will divide this part. So just I told this special theory relativity, we have a special 2-hour class. We will discuss this basic postulates, all the formulas, and then we will solve some problems. And then I will give an assignment to you, and you solve it. If you have any issue, discuss it with me. Okay.
Okay, sir.
So similarly, we will have this other thing is this Lagrangian and Hamiltonian formulation. If you look at the paper, you will see a lot of problem comes from this part. So basically, the Newtonian mechanics is a kind of very, when you solve practical problems. So the Lagrangian and Hamiltonian formalism is more evolved and more systematic, and it is able to provide better solution for the problem. So this formalism is kind of it takes this coordinate invariance when we talk about different coordinate system and all. So this is if you see the generalized coordinates. Generally, we have in Newtonian mechanics we have x, y, z, 3 dimensions and all. So here, when we talk about rigid bodies and degree of freedom and etc., then there is a term where you define maximum degrees of freedom of a system, and according to this, you define a coordinate system. So that coordinate will be used in Lagrangian and Hamiltonian formalism, and from that you make an equation of motion. General thing is that in Newtonian mechanics we make some basic laws, and from that Newton's laws are there and some other equation of motion. From that you solve a problem. So this is a completely new formalism for solving problems which is not easy to solve with Newtonian mechanics. So first we will discuss Newtonian mechanics. We will revise basic our basic understanding, and then we will develop read this Lagrangian and Hamiltonian formalism. So how many of you are have studied it before, Lagrangian Hamiltonian formalism in some detail? Means in MSc we had to have a classical mechanics course, but
Yes.
what kind of understanding, what kind of knowledge you have about it? Do I need to start from very basics, or is that kind of thing I need to know?
So no,
Mm,
I think we
I
can start from basics, but when we come to the point at that time, you can explain if you don't know that particular thing.
I
Okay,
studied
so we
I
will.
studied all these things, but can't remember at this time.
Yeah. Means almost we all who have passed master's degree in physics, they all have studied it at some time. But as of now, we may need. So one thing I will suggest that.
Actually, I teach this subject, but can't remember it right now.
Okay, that's all right. That's all right. We all on similar ship. So
The different problems, each problems are different. I think so in Lagrangian.
yeah, in Lagrangian, actually, I think in one class, I will completely means I am planning to devote 2 classes for this Lagrangian Hamiltonian formalism and equation of motion, and generalized coordinate, conservation laws, and cyclic coordinates. So this topic we will take in 2 classes, and we will develop from starting complete formalism for this, and after that we will solve problems, and then I will share assignment with you. Okay,
Okay,
and
sir.
basically our assignment is question from previous papers. We will take some standard books as a. I have J.C. Upadhyay's book. That book is quite a better book for classical mechanics, because if you go foreign authors, then foreign authors have something more details, and that probably we don't need for this exam purpose. So for this exam, J.C. Upadhyay's book is better, and I will share J.C. Upadhyay soft copy with you. If you don't have hard copy, you can use it from your computer.
Okay.
You will get
Okay, sir.
problems there, and there are a lot of theories is written there. So we will basically, and then so this is last part we talked about. Then we are talking about Lagrangian part, and this is the first part where Newton's law, stability analysis, how we identify that equilibrium. There are sometimes you have very simple question in exam that this equilibrium is stable or unstable. What equilibrium ka condition kya hai? What is the condition for equilibrium, and whether this system at this point at stable equilibrium or unstable equilibrium. Newton's law and friction force. What are the conservative force? So the basic terminology. Today, basically, it is very introductory class, so I will tell some very fundamental definitions, some fundamental things in few slides, and so so we start with this Newton's law and all, and then we will see. And for the Lagrangian and Hamiltonian, we will have we develop class, but before we need to have some basics of mechanics. So that mechanics maybe the same thing as when we are studying nuclear physics, that they will not ask any fundamental definition or fundamental thing, but we need to know to solve their problem. I think this in nuclear and nuclear particle physics part, we have done things in a proper way. If we collect it, make a proper notes, and if we solve all the problem, I think any that the questions we will be able to handle in exam. I hope that. So there are some questions we still need to work. Okay, so almost I think nobody is there now. Only 2 people are there. Okay. So this, can you see this next slide?
Yes.
Yes, sir.
Okay. So here in this slide, it is just very basics, but I want to put some basic formula and basic definition. So there are 3 laws of Newton's. Newton's 3 laws. The first law is law of inertia. So law of inertia basically says a particle which is not acted upon an external force maintains a state of rest or state of uniform motion. So from there, if you remember, there are 2 kind of reference frame has been defined. One is inertial frame, other is
One is
non-inertial.
non-inertial.
Okay. So so if I ask you what are non-inertial frame?
So that
The
do not
rotational
change velocity with respect to fixed frame of reference.
Okay. So basically, they have some acceleration. Accelerated frame of if there is some
accelerated frame of reference.
Frame of reference.
accelerated frame of
I have
reference.
a doubt.
Yeah.
रोटेशनल फ्रेम्स नॉन इनर्शियल फ्रेम ऑफ रेफरेंस होते हैं.
Rotational frame of reference. Rotational motion, we need to study.
Actually, I am saying any rotating body is included in non-inertial frame of reference or inertial frame of reference.
Frame of reference, basically, means I'm not getting your question properly. Rotating body is a frame of reference. Frame of reference is a kind of coordinate system, a system where we make measurements. So when we are making a measurement, so the inertial frame of reference are those frame of reference which move at constant velocity. They don't have any acceleration. So any
Yes, I am trying to say a set of observations which are rotating. Any observer which have rotational motion except of linear motion or constant motion. Is it non-inertial
so
frame?
if there is a rotation, if there is rotation, means if observer who is who is rotating with respect to a measurement where it's taking, so it is an acceleration. Rotation has an acceleration. Rotation is not a constant velocity. Rotation means direction is changing all the time. If direction is changing, means it has an acceleration. So if it has an acceleration, then it is a non-inertial frame.
Okay.
Okay.
Yes, sir.
So this first law says this law of inertia: when a body is at rest, it will be in rest, or if it is in motion, it will be in motion. Still, there is no external force acting on it. So ideally, we don't have inertial frame of reference. When we say ideally, it is really difficult to say any practical example of inertial frame of reference, but it is an ideal definition. So in those frame of reference, law of inertia is valid. They are called inertial frame. So this is this definition comes from when you say this violation of Newton's law. So this first, second frames are strictly valid in inertial frames. So It is like you say either this or that. On the basis of this, inertial definition of inertial frame has been made. So we also have in our syllabus what is inertia and all. So probably we are aware about the basic definition of inertia. Inertia is a tendency of a body to oppose its change of state.
Changes of
And it is motion, it opposed to if you change its state, if there is motion or in rest. Actually, rest is a kind of easy definition for us, but nothing is at in rest in this universe. Everything is in motion. So if two things are moving in a constant velocity, it appears to us as a rest. Nothing is in rest. So when you say maintains its state of rest or state of uniform motion, it is respective to the observer. Okay, if you are sitting in the same frame of reference where body is sitting, then it is an state of rest. So if somebody asks this body is in motion or in rest, so we have to, if very specific, we need to ask them from where you are, for a reference point, from where you are making measurement. So most of time, it is very important when we are talking about any measurement and all, then we need to understand what is our frame of reference, from where we are taking observation. So classical mechanics is our Newtonian mechanics is valid up to some extent. They, if you see the Newton's law are not valid for a coordinate system. If you know, this is a some equation from Newton's law, and if you change coordinate system, simply if we say this is second law is the rate of change of momentum of system is equal to the resultant force on the system. Okay, so this is the case. If we consider a particle moving in x direction, so we can write fx is equal to dmvx by dt, x direction. Similarly, we can write it for three other dimensions x, y, z. But we cannot split similarly in case of if we consider spherical coordinates. You know, spherical coordinates where r, theta, phi are the
theta
system.
phi.
So similarly, we can't, as we can write the x component, y component, z component independently in a Cartesian coordinate system. Similarly, we can't put equal that coordinate system, a spherical coordinate system for Newton's law. So Newton's law, there is a limitation, there is a constraint where it doesn't work properly. So that is why we need to develop some other mechanism. We need to understand. That is how it comes, relativity and quantum mechanics and all. So, but they are valid for some crude thing when we are looking and general mechanics. It is okay. So and third law is to reaction, there is equal and opposite reaction. So this law is valid almost everywhere, but there are some examples. When you say there are two wires carrying current carrying wire, but their attraction force, and somehow that force doesn't comply with this Newton's third law. So there are exceptions for this all three laws. At the time when Newton told this law, people were thinking that these are universal law and everything can be explained with that. But later on, it is found that they are very limited. They have success in a very specific frame of reference. So we all know these all three laws of physics, but just for revision, quick revision for basics, so that when we develop our classical mechanics formalism, we must be aware about this. And other thing is the conservative force. So you will see some question where they ask on conservative force. So we must be aware about what are the conservative force, how we know they are conservative force, and what are the property of conservative force. So we need to make some macro notes on that, that kind of notes, so that if you go in a book, you will need much more detail. But for exam purpose, we can't go into that finer details. While we are solving question, we are doing tutorial, you make a separate copy for micro notes, kind of macro notes. So in that note, in a small copy, you will have everything. So while you are solving problem, you will get a method. Earlier, I was solving a problem in nuclear particle physics, that mirror nuclei thing, and I found a method to determine radius of nuclei using mirror nuclei method. I shared the screenshot with you. I think everybody could understand that. So that kind of thing, and we can put it in when we are making notes for nuclear particle physics. We can put this thing in basics when we are saying nuclear radii and define it. Where we can put a method to determine this. So that note.
So whenever the mirror nuclei comes, at that time we should use the same method.
That question was there. So there are few techniques to determine nuclear radii. So there are some techniques. So this is a method basically when there are some experimental methods, scattering experiment and all. But this method was easy method, and we have seen an problem on exam in exam. So they may ask some similar question. They may change some nuclei, and they may ask something different, something. If they say radii, and they may ask force, because we have a formula, we can calculate force between them, and difference they can say one thing and ask other thing. In that question, they have given this Coulomb energy term difference, 6 maybe, and they ask radii. So in other questions, they may give radii, and they may ask what is the difference between Coulomb energy term. So
No, sir, not
if
that
we are
way.
aware about, yeah,
That n is equal to and z is equal to, we have written in terms of a minus b
yeah,
by, yeah, that
mm-hmm.
one, that same method, that for all
Yeah,
mirror
means there
nuclei.
are they can make different kind of question on the same method. So if we know the method, whatever they ask, we can solve. And it was easy one, but before solving, it was difficult for me. When I was not, I was thinking what it is. But if you take a systematic study, what is mirror nuclei, and then how to solve it, you will get things. So that kind of notes you try to prepare, because when we are doing a lot of classes and tutorial and all, but it is a kind of guidance. But main thing we have to do, we have to make notes, and we have to write problems and solve. We have to practice it, or so that kind of thing is there. So here we discuss what are the Newton's law, and then conservative forces. For conservative force, curl of force is 0. So anytime if means there can be many question on that kind of topic. They have given a force, and they ask whether if it is conservative or not. So you can calculate curl of that force. If it is 0, then it is conservative. Okay. Then said work done by a conservative force is independent of path followed. So that kind of some property, but from that properties you can handle the problems. If they ask some problem related to conservative force, sometimes you do some part of it, and you are able to get the answer. Then work done along a closed path is 0. If it is a closed path, work done will be 0. Gravitational and electrostatic forces are conservative, and frictional and viscous forces are not conservative. So in few lines, we may have, if we go in a book and try to read about conservative force, we may get some new things as well. But here in few sentences, we are able to tackle many things. And if there is some problem related to conservative force, we may get the clue to solve it. Okay. So the next thing is potential energy. So work done by a conservative force in taking system from given configuration to reference position. This is a definition of potential energy. Potential energy, basically, if you talk about electromagnetics, so there is a test charge. If you take test charge from infinity to the field,
Infinity
work
to
done,
the point. Yes.
yeah, so the work done is equal to potential energy at that point. Okay, so similarly here we have a general thing. So here we are developing it a potential energy formula. We can use this formula for electromagnetic. We can use it for gravitational potential energy. So So this is the definition. Potential energy is equal to minus F dx. F dx is kind of work done and total work done, and negative is because of this comes from you have to do work, you don't get the work. So this sign is there. Then for gravitational potential energy, you know the formula for force. F is equal to minus G m1 m2 upon r square. You put it here, you can calculate gravitational potential energy. Similarly, you can calculate electrostatic potential energy because electrostatic forces and gravitational forces both are conservative forces and very similar nature. Here it will be 1 upon 4 pi epsilon naught q1 q2 upon r square. So here you will get the formula. So potential energy, and we studied Newton's law. What are the conservative forces? What is potential energy, and how to calculate gravitational potential energy, electrostatic potential energy. So that kind of very easy topics I am trying to share with you to quickly revise very basics of mechanics. So this in this formula for kinematics, uniformly accelerated motion, where acceleration is uniform, we have three equations of motion. As we have three laws of motion, Newton's laws of motion. Similarly, we had three equations of motion where if a constant force acts on a particle. So these equations are valid in the condition when acceleration is constant. So we have solved many problem in our earlier classes. From I think from 9th, 8th, we start solving this.
Yes.
So that kind of the three equations. Sometimes we may need these equations in when we are solving problems, but these equations we remember. But just to revise things, I have put it on in the slide. So if acceleration is not constant, if acceleration was constant, we have these equations. From that you can calculate equation of motion. These are basically equation of motions. So for if acceleration is constant, then we start with basic definition. Velocity is rate of change of position, acceleration is rate of change of velocity, and from that acceleration we can write in terms of motion. I will share this PPT, this presentation with you all.
Can I ask a question?
Yes.
There is a velocity distance graph, straight line graph with retarding values, straight line graph with retarding velocity, decreasing velocity. What kind of graph we can draw it for acceleration and distance?
Okay, means that kind of questions generally when you are preparing for IT kind of exams after
yes,
12,
yes.
that kind of questions. So for that, basically, if you have a plot for velocity, it is basically a slope of that. Means I can't exactly solve the problem, but as of now, I understand velocity versus velocity time plot is given, and you are asking acceleration and time plot. No?
Yes, sir.
So here, basically, if you have a plot, so it's slope. From that slope, we can calculate acceleration, and how it varies, we can do it from. But I need to have a problem, and I need to look at this. I can't tell you what is the plot, because those people who are preparing, they practice it, that kind of thing, so they can solve at the exact time. But there are some basics we have to practice it if we need. And sometimes we may see some that easy type of question, but probably in our exam we can't see that question.
Yes,
we
yes.
have much in part A we may say something, some plot kind of thing, but we will practice all previous year exam questions, and that kind of problem also we can solve, and I will try to put, if we can put it in our assignment and all. So I'm thinking to make an assignment for some level 1 kind of some easy problems, and then level 2 some moderate problem, and level 3 for part C. Means part B and part C we will have separate assignment, and we will have some very elementary assignment. So that kind of sheet I will try to prepare. So this is basically from this slide I'm trying to tell that if a motion is uniformly accelerated, then we can use this equation of motion. If uniform acceleration is not there, acceleration is not constant, it is changing, then we will start from this definition when we are solving problems. Other thing is that we will see some problems in exam related to that spring force. So for that spring force, there are a spring and a spring. If you stress spring or compress, there is a force to push it to the original state. So that force is a restoring force. This is will have some problems, some questions regarding to spring kind of problems. So where a spring is stressed, spring is compressed. So if there are problems, general problem is simple pendulum problem. You have the small oscillation, and then you see that pendulum. There is a force directed on pendulum to push it on equilibrium. If you put it on left, there is a force which will push it to the equilibrium. When it goes to right, there is a force which pushes on the equilibrium. Means force is directed against this negative sign is here, minus kx. So this force will be there, and from that force, this potential energy can be calculated. Potential energy is the same formula in the last slide when you wrote this formula for potential energy. So U is equal to minus F dx, where F is minus kx here. So we put U is equal to half kx square. So spring potential energy can be calculated by this, and force is always minus kx. These are some basics we are discussing here. We will solve problem for this, then it will become easier to understand.
I have some basic doubt. It's very simple.
Yeah,
What is the
Soumya.
difference between potential and potential energy?
Potential and potential energy. So basically, if you see this,
And V. Yes.
In this formula, if there are two masses, G m1 m2 divided by R, it's energy. But if it is regarding with single mass particle, either m1 or m2, it is potential.
Okay.
yeah. So if you see electromagnetic thing, potential is defined by as U is equal to 1/4 pi epsilon naught Q by R. And if you
Yes,
say
sir.
electrostatic potential energy, so it is 1/4 pi epsilon naught Q1, Q2 upon R. There are pairs. So
Yes.
basically, similar kind
For
of thing where
energy,
you have
I want to say something.
yeah.
For energy, we must have another particle who can feel that energy. For potential,
Okay.
we have only the source thing. Either that can be mass or that can be charge.
Yeah, potential is kind of a field. It has
Yes, sir.
value at every point. But if there is some mass, some charge is there to feel it, then it is potential energy for that particle. But at the point, that is the potential. So if you say there is a charge m2, there is a mass m2 is there, so that is the potential energy of that system. But if there is no mass, so at that point there is some potential. Okay. So similarly, we calculated that gravitational potential energy. Similarly, the spring potential energy is there. We can calculate with the same formula. So we will solve some spring problem. Then we are going to use that kind of definitions. So today, basically, and this is one thing. In one slide, I have kept everything regarding projectile motion. If they ask anything, any question on projectile motion, you just need to know this much. So from this much you can calculate. So sometimes they ask some question 3.5 mark part from this projectile motion and all. So we all have done this, but if you have this slide and you do 3-4 questions, I think you can do anything. Any problem on projectile motion we can solve. So here, basically, we all know this. This is the point where this vertical component becomes 0, and then so R range, a range of this is given by this formula. This is equation of motion. First equation is equation of motion. Y is equal to x tan theta minus gx square upon 2u cos square theta. Where means I have written all the formulas. This is range of the projectile. If it starts from here, so this is the range of projectile. If there is a situation when they ask a problem where they
Maximum
put
height.
something on height from A, if start, this point start from A, so you can calculate this range is half of this. And this is the maximum height, formula for maximum height. This is for time period. So we don't need to do all derivation and all, but we can, if we solve few problem on that, we will be able to deal with that. So I will look into problem related to projectile motion. If they have ever asked this in exam, probably they have asked some questions, and sometimes you need to apply this. They ask something different, and you need to use that kind of formulas. So these are the basics. I think we have to be ready with that. Then frictional forces. So frictional forces, basically they are non-conservative forces, and there are two kind of frictional forces are there. One is static friction and kinetic friction. The static friction is has more value than kinetic friction, and I haven't written formula for that. So I was actually putting the things which we need to work on. So this formula is not there, but frictional, there are problems I have seen in exam that they ask some problems related to frictional force. And then the centripetal acceleration, centripetal force, when there is a motion, uniform motion in a uniform circular motion, if you say, there is a force which acts towards center, and that formula is given by this, the centripetal acceleration. This is the force. Kinetic energy we can write in terms of sometimes we need to use this formula, sometimes we need to use this formula, and work energy theorem is this. Work is done by kinetic energy final minus kinetic energy initial. This is for a conservative force system. If force is viscous, non-conservative force, then there will be loss. So we have to incorporate it. Conservation of mechanical energy. If only conservative forces are acting on system, then total mechanical energy of system remains conserved. So this is basically work energy theorem is also valid when this is conservative forces. And this is, there is one term called impulse. So sometimes they give something and you need to solve the problem. So we need to have definition. Impulse is change in momentum of object. How the momentum is changing. So basically, P final minus P initial, we can write it integral f dt. This is the basic definition. We will, I suggest to make notes in a way, some notes for classical mechanics type of part, central motion, and Lagrangian, and we will have some notes for Lagrangian. That is completely different kind of thing, but for that basic, we need these basics. So we will not go into much detail of this mechanical part, that mechanics, normal mechanics. Probably we have to look what kind of question they ask in exam from that part. But I have seen they ask a lot of questions from Hamiltonian part, and this Hamiltonian part, and this thing is common in part C as well. So that is in much detail. We will go into much detail for that. And from this Newtonian part, we will write formula in 2-3 pages, and then we will solve problems. After we do practice good amount of problems, I think we can do it. So while preparing test also, I found that kind of, there are some problems where you need picture, sometimes so there are some problems where you need equations. So for that, I think it is better to make a assignment sheet. So that sheet will be better to easier to communicate, and for you also, you will be able to solve it in a very specific way. So there is some limitation with online classes. So we can't write here, we can't solve it here. A whiteboard or board, there is an option for board, but on the board it is difficult to solve problems. So first of all, I will make an PDF copy of assignment sheets and will share with you.
Okay, sir.
Okay, sir.
Okay, then angular momentum. Angular momentum, what is the angular momentum, what is torque, and how angular momentum is conserved. This is, I've written some basic definition of, everybody knows that, but we probably need to revise it for that when we are solving problem, we can put the basic definition in the picture. So momentum, if P is the momentum, R is the position vector with respect to a point O. So angular momentum we define as L is equal to R cross P. So basically, vector thing we also need to keep in mind that the cross product R cross P is not equal to P cross R. And force acting on a point, R is on so torque is defined as tau is equal to R cross F. The force acting on a particle, R is a position vector, so torque is this. We know this from Newton's second law, F is equal to dp by dt. Rate of change of momentum is equal to force. And so if you put that definition here, the tau becomes R plus dp by dt. So that is equal to dl by dt. R is not time dependent. So we can put this in terms. So from that, if tau is 0, in a situation where torque is 0, external force is not acting on it, then angular momentum will be constant. This is the conservation of angular momentum. So angular momentum conservation, and we will read this, we will study this angular momentum conservation, energy conservation, and specifically collision. We will deal collision in detail, all different possible cases when elastic collision, inelastic collision, and what is conserved in elastic collision, what is not conserved in inelastic collision. We will discuss in next classes. And then one thing comes stability analysis. When we do stability analysis, means here we need to find equilibrium position. There is a system. So there is a system. So we need for the system, we need to find equilibrium position. And then if we want to know this equilibrium is stable equilibrium or unstable equilibrium. So for that, if V is a potential particle moving in a force acting on this, F is equal to minus dV by dx. So at equilibrium point, force will be 0. Therefore, the condition for equilibrium will be dV by dx. So if potential is given in terms of x, y, z, whatever it is. So if we differentiate with respect to that parameter, we can find out where force is 0. Force is 0 means equilibrium. For an equilibrium, there should not be any force. Resultant force is 0, then system will be in equilibrium. So then how to find out which one is stable equilibrium, which one is unstable equilibrium. So for a stable equilibrium, we need to make a second order derivative of dV by d2v by dx2, and if that is greater than 0, then we can say this is stable equilibrium.
Stable equilibrium.
And if it is less than 0, then we say this is unstable equilibrium. And unstable and stable equilibrium, if we had some pictures, I think we could have explained much better way. That in a stable equilibrium, if you push particle which is in a stable equilibrium, it will come back to that equilibrium point. But if it is an unstable equilibrium, if you push that, it will go. It will lose that equilibrium. So that is the basic definition of stable and unstable equilibrium. And here, how to find it out, if system is in a stable equilibrium or not. So I have written it in a very simple way. That's one-dimensional case. But we will look, because stability analysis is in part B and part C, both part of the syllabus. This is mentioned. So probably we are going to have a lot of problem on that. So that problems, this is very basic understanding. When we are solving problem, we maybe need much evolved techniques, but this is the basic definition. From that, you can understand what is equilibrium, and how to find out the equilibrium position if potential is given, and how to find out if potential is this equilibrium is stable or unstable. Then the frequency of oscillation, if particle of mass m moving under potential, if this is the potential, then frequency of oscillation will be root k by m, about stable equilibrium. So these are some basic, very basic definitions. So here I have defined what are non-inertial frames. Non-inertial frames are that are accelerated. So in non-inertial frames, what happened? Newton's law are not just as it
No
is.
topic.
There are some. It appears there are some other forces also acting. So that forces are called pseudo forces. To write equation of motion, you need to write a term for pseudo forces, because direct this Newtonian equation of motion by direct using Newton's law will not give exact solution. So there are some pseudo forces. They are known as pseudo forces or fixed forces. So centripetal forces, we know there are some centrifugal force. So that kind of forces are called pseudo forces. Then other thing, there is the simple pendulum. We need to know the time period for simple pendulum in linearly accelerated motion. So time period is given by t is equal to 2 pi L by g. If simple pendulum is suspended in such a way that point of suspension move with acceleration. जैसे ऐसा कुछ problem when you have an pendulum in lift is stationary and the lift start moving with some acceleration. So that acceleration, how to take it with if they ask how to calculate time period for that pendulum, so that pendulum time period will be this g. The g is the gravitational acceleration, and that other acceleration, if it is lift is moving up or lift is going down, whatever the part of is, that will be added or subtracted from g, and you will have new time period. So today's class basically we will wind up here. Today we lost 1 hour, and there was a test. I prepared a test. I was thinking to have a common access, means what kind of information you already have, but I'm not able to do that. I don't know how to start the test thing here. So today basically we discussed syllabus, Newton's law, and some very basic definitions for revision. And I will share J.C. Upadhyay's book to all of you. And from next class, I will take a topic. So
Okay.
probably I am going to take this first part what we discussed today. In next class, we will do problems on that, and we will take this. We discussed Newton's law, some dynamical systems, spring, and some non-accelerated motion and all. stability analysis we discuss. In next class, we will discuss collision in detail and the conservation of linear momentum, angular momentum, and problem on that basis, on that whatever we have studied. Actually, this is very basic, and I think we don't need to devote much time on that. Rather than we will solve problems on that part. So Newton's law, dynamical system, stability analysis, and this non-inertial frame and pseudo forces. These few topics we tried to touch on. We haven't gone into very detail of that, but I think if we solve problem on that, so in next class we will solve problems on these topics which we discussed, and I will put notes for collision and problems on that. So this will be next class. We will have next class on Wednesday.
Okay, sir.
Okay, sir.
So it seems this Kritika, you will wind up today, and from next class I will solve. I will put problems on the sections we touched upon, and I will try to make a tutorial for that, and I will share this collision thing. So if you have time, you can study collision from that book. I will share that book as of now and the slides as well. Okay.
Okay,
Okay, sir.
Okay, sir.
Okay. Thank you.
Thank you.
Thank you,
Good night,
sir.
sir.
Good night, sir.
Right.